Mutual information. These notes are adapted from the paper by Kenneth W. Church and Patrick Hanks, Word Association Norms, Mutual Information and Lexicography, which first appeared in the journal Computational Linguistics. Mutual information compares the probability of observing word X and word Y together, the joint probability Pxy, with the probabilities of observing word X and word Y independently, which are called Px and Py respectively. The formula for mutual information is Ixy, which stands for the mutual information between word X and word Y, equals log to the base 2 of the ratio of the joint probability Pxy over the two independent probabilities Px and Py. If there is a genuine association between X and Y, then the joint probability Pxy will be much greater than the chance co-occurrence, which is Px times Py, and thus Ixy, the mutual information between X and Y, will be well above 0. If there is no interesting relationship between X and Y, then Pxy will be about the same as the product of Px and Py, and mutual information will be about 0. Finally, if word X and word Y are in complementary distribution, then Pxy will be very much less than Px Py, making Ixy much less than 0. Word probabilities Px and Py are estimated by counting the number of observations of word X and word Y in a corpus, which we call Fx and Fy, and normalizing, which is dividing by n the size of the corpus. The joint probabilities Pxy are estimated by counting the number of times that both X and Y occur in a window of W words, which we can call F underscore W XY, and normalizing by n. The window size is typically set at 5 words. In this example, we look at the mutual information between two words that we might expect to occur together, doctor and nurse. In the Associated Press corpus, the word doctor occurs 1,105 times, the word nurse occurs 241 times, and the two words occur together in the same window 36 times. There are 15 million words in the corpus overall. So the probability of doctor is its frequency in the corpus, 1,105, divided by the number of words in the corpus, 15 million, which gives us 7.367 times 10 to the minus 5. The probability of finding the word nurse in the corpus is the frequency of the word nurse, which is 241, divided by the size of the corpus, 15 million words, to give us 1.607 times 10 to the minus 5. The joint probability of the words doctor and nurse is their co-occurrence frequency, which was 36, divided by the size of the corpus, to give 2.4 times 10 to the minus 6. We now combine these three values into the formula to find the mutual information between doctor and nurse. This is equal to logarithm to the base 2 of the ratio 2.4 times 10 to the minus 5, which is the joint probability, divided by the product of the two individual probabilities, P doctor and P nurse. This gives us a value of log to the base 2 of 2027.2, which is 10.66, a positive value showing that these two words have affinity for each other.